Hello friends, welcome back to my channel Kiki Cody, and here I am with another interesting video on the singleton design pattern. This is one of the most important technical interview question, and if you are well aware with the concept and the pattern, then there's good chance to crack the interview and to impress the interviewer. Please like, share and subscribe to my channel if you have not yet subscribed. Also, let's start with the video. We are going to cover the following topics today: the overview and introduction to singleton design pattern, various ways to implement the singleton design pattern in your code and application, when to use the singleton design pattern and when not to use, advantages and disadvantages, also the default singleton pattern implemented in JTK. In addition, we will be covering how to make a class singleton safe, or how to ensure the singleton behavior of the class in case of multi-threaded environment, and if the class is serializable, clonable, and also in case of reflection and multiple class loader. In order to start with the singleton design pattern introduction, let's first talk about what is design patterns and why do we need it. So the design patterns are nothing more than the solution to the common problems or the recurring problems that developers and software engineers face while designing and providing solutions to a common problem. So the design patterns are kind of template. They define how to approach to a particular situation and the solution to a problem, but not the code. So they don't provide a code, they just tell how to solve the common situation without giving you the implementation. And also the design patterns help you in high readability of your code, because everyone can understand your code if you mention the design pattern name and they are familiar and aware of the code. Also, it helps you in faster development because the design patterns are already tested and tried solutions to your common problem. There are various types of design patterns like creational, structural, behavioral, and singleton comes in the category of creational design pattern, where we control and provide the template how the object should be instantiated if we have the situation where we need to use the singleton design pattern. So we need the singleton design pattern when we have the situation where only one object of the class should be created throughout the application, and whoever is calling our class get only the same instance that's already instantiated. For example, if we have a scenario where we have the loggers for logging the application, the driver objects, the connection objects, the caching, and the thread pool. So in those scenarios, we only need one object throughout the application. We don't need multiple connection objects. So in all those kind of scenarios, our singleton design pattern is the best solution. The purpose of the singleton design pattern or the singleton class is to control how the object should be created, limiting the number of objects of that particular class to one. Also, it provides one entry point to create the instance of the class, so it provides the global variable access to the class. So in short, the singleton design pattern is a type of creational design pattern that ensures only one object of the class is created, and that object is available globally or publicly throughout the application or code. Now let's move ahead with the various implementation of the singleton design pattern, or how to implement it in your application. Let's start with the simple implementation of singleton design pattern. Here, in order to make a class a singleton, we have to ensure two things. The first is that the class object cannot be created from outside the class, because if anyone can create the object of the class, then it won't be singleton. Anyone can create any number of objects in that case. So that's why in the second block of code here, we are restricting the access to the constructor so that no one can create the object of the class. We have made it as private. And the second condition that we have to ensure is to make the single object instance of the singleton class as global. So that's why we have in the first piece of code created a eager singleton class variable that can be accessed globally, as we have made it as static, and we have instantiated it here only with new keyword and by calling the constructor. So that's why we call it as eager implementation, because we are calling the constructor at the start of the application by making it static and by creating the new object at the same time. Also, we can add a static method getInstance where we are returning the object variable. In case if we want to create the object of the class, we can call this method getInstance and it will return the same object every time. Also, we have made the instance variable as private here, as it's always a best practice to make the instance variables of the class as private. Now we'll discuss about the lazy loading of the singleton class. In case of lazy loading, we have some benefits compared to eager loading. The benefits are better performance, better resource utilization, better application load time, because here we are creating the objects at the time when we need it, not at the start of the application. So in order to make the class as lazy loading, here what we have done is the instance variable we have make as null. We are not instantiated it in the starting, and whenever someone calls this getInstance method, so we are first checking if the class variable is already instantiated or not, is not null. So if the instance variable is null, then only we are creating a new object and returning the same variable. If the if condition fails and we have already instantiated this class, then we are returning the same instance variable or the same object to make sure that only one object of the class is created. So again, we are creating only one object of the class because we are calling the constructor only one time inside the if condition and in getInstance method. The implementations that we have discussed so far have the drawbacks in case of multi-threaded environment, because if there are multiple threads, for instance if we consider two threads working in the application parallelly and both threads try to call the getInstance method at the same time, then it's a possibility that they will end up with two object instances, because the if condition that where we are checking if the object instance is null, so for both the threads the condition can be true and both will result in creating different objects, and in that case the singleton behavior will be violated. Now we have to ensure that our singleton class should be multi-threaded safe, and so to make sure that only one class object should be created if there are multiple threads running, what we have to do is we have to make the getInstance method as synchronized. So in case of synchronized, one thread who will be calling the getInstance method first will get the lock of the method, and once the first thread gets exit from this method, the getInstance, then only the second thread would be able to enter the method, and in that case the if condition singleton object condition is equal to null. The if condition will be failure for the second thread, and so it will not result in creating second object, and we will be returning the older object of the same class. Now if we want to use the synchronization with singleton design pattern, so there's another technique called as double check locking mechanism. So here it will help to reduce the use of synchronization and to improve the application performance. Here what we will do is we will add two if conditions inside the getInstance method, and with the if condition we will check if the instance is created or not. If not, then we will synchronize the second if condition, else we will proceed without synchronization. So for instance, let's take the example of two threads. If there are two threads calling the getInstance method at the same time, so the first thread suppose enters first in the if condition, both threads check the if condition sc is equal to null. So for both the threads the condition may be true, and first thread any of the one will get the lock with the synchronized keyword. So the first thread that will enter the synchronized block is going to create the first object of the class and will be exiting the synchronized block. Then only the second thread who was waiting for the class object will get the lock and will proceed with the synchronized keyword. So inside the synchronize, we have again checked the condition if the object variable is null or not. If it is not null because we have already created the object with the first thread, so that's why it will exit the if condition and will return the same object created by the first thread. And if we have another thread, thread 3, after first and thread completes the execution inside get instance, then that thread also checks the first if condition. So the if condition fails, going now onwards, the if condition fails and all the threads or all the methods that are calling the get instance don't need to synchronize and get the lock of the object, because the first if condition gets failed. And that's why and how we are increasing the performance with this double check blocking technique. What we have discussed so far, there are other ways to break the singleton pattern, like if the class is serializable, clonable, or it can be broken by reflection API as well, and also if the class is loaded by multiple class loaders. So all these scenarios we can break the singleton class behavior. So let's discuss in more detail how to ensure the singleton behavior in all these situations. Here let's discuss about the serializable behavior in case of singleton class, or we can say how we can ensure the singleton behavior if the class is serializable. So in case of serializable class, we have to make sure that the class or the same object of the class gets serialized, and when we are deserializing back to the object, we will get the same object only. So in order to make sure that we have the same object, we have to override two methods. The first one is read resolve and the second one is write replace. So this method will be called during the serialization and deserialization of the class, and read resolve will be called at the deserialization time. So here we are returning the same singleton class object that we have created in the get instance. Also in the write replace during serialization, we are returning the same object as in read resolve and that we have in get instance method. So in this way we can ensure that the serialization and deserialization won't violate or impact the singleton behavior of the class. Now let's move to the clonable singleton class. So if the class is clonable, or if someone tries to clone the class object, then how to ensure that singleton behavior? So here we have to implement the clonable interface, that's the marker interface. So we don't need to override any methods from the clonable interface, and we have to override the clone object class method. So here we have to throw the clone not supported exception, because we don't want to create any other instance of the singleton class object. So in this way, if anyone tries to get the clone of the object, the singleton class, they will not be able to do so and get the exception that singleton cannot be cloned. Let's move ahead with the singleton behavior in case of multiple class loaders and how to ensure the singleton behavior. So here, if multiple class loaders try to load the class, the singleton class, then we have to ensure that the same class loader will be returned and the same class loader will be used to load the class. We don't need to load the class multiple times. So here we have to override the get class method that the class loaders use to load the class. So here inside the get class method, we have to first check if the current thread that is running have any class loader. If we already have the class loader, we are well and good. We can return the already loaded class from that class loader. If we don't have the class loader, or if the class loader is null for the current thread, then for this singleton class we will get the class loader and we will load the class with the help of the singleton class loader that's already in place. So in all the scenarios, we are first checking if the current thread class loader is existing or not. If it is there, then we are returning the class from that loader, else we are creating the class loader from the already loaded class, the singleton class, and using the same class loader to load it. Although we have so many ways or techniques to implement the singleton design pattern that we have discussed so far, but there is one simple and very easy way of creating it. As of JDK 1.5, we have enums and we can create a singleton class using enums. The enums constants are implicitly static and final, so we cannot change their value because they are final. And if we try to instantiate an enum object, then we will get the compile time error. So it's not possible to create another object of enum. Also, the enum gets loaded statically, so there is no chance of thread violation of the singleton behavior. The clone method is final, which ensures that enum constants never can get cloned. During serialization mechanisms, or the serialization ensures that duplicate instances are never created. During deserialization for enums, reflection is also prohibited here. So all these things ensure that no instance of an enum exists beyond the one created by the enum constants, and this way the enum singleton is the most effective and best way to implement it. Although we should know all the implementation ways of the singleton design pattern for interview and for our technical preparation. Let's discuss about the singleton implementation is JTK. So we have many classes that's implementing the singleton behavior in Java API. So here we are sharing some of the examples like runtime, action servlet, calendar. Now let's pour some light on the disadvantages and drawbacks of using the singleton design pattern in your application. Ideally, and in happy scenario, you should always avoid using the singleton pattern in your application if it's possible. So the drawbacks here are it makes really difficult to test your application, and for unit testing it's not possible because you cannot create another instance of the object for testing. Apart from that, it violates the dependency injection and inversion of control, because here we are creating the object inside the class, so it hides the dependencies. Also, it provides tightly coupled code, so that's why we should always avoid using singleton design pattern whenever possible in the application. I hope my video helped you now in better understanding of the singleton design pattern. If you still have any questions or doubts, please put in the comment section, and please subscribe to my channel. See you in my next video, and happy learning.